Cool. So hopefully you guys can all hear me. I should be unmuted. So we had just finished solving for the power of R4. And now we can move on to something else. Let's see. At R4, these two are in series, so they should have the same I believe. Double check. Yeah, same I. So we actually do need something from our past work. We need our I124. Okay. Our V12, because we already calculated for that. V124 was 2.2 volts. Go ahead and grab that, bring it back over. I'll start a bit higher this time. Hopefully we won't run out of room so soon. Okay. 124. Which is going to be the same for V12. And we already used the V4 there. So all right, because so then for V12, R12, and R12. Again, we have our R, we have our V, we're going to be solving for the I. I'll just rearrange it here. V, 2.2 volts divided by our calculated R. R12 is 7 ohms. That's 0.31, which feels a little small, but we can check right now. Anyway, we have resistors, which have I believe these are in series, they have the same I. So yeah, R1 and R2 are in series, so they have the same I. So I12 is equal to I1, which is equal to I2, because series. Which means that this 0.31 is the same for I1 and I2. I'm just gonna go ahead and move this just to see if we're right. Okay, cool, that is right number. It just seemed a little small. 31A, 31 ampere. And then from there, I'm pretty sure the rest will be pretty easy. From there, we can go, okay, we have the R and we've got the I for 1 and 2. So we can go V of 1 and V of 2 is equal to I1 times R1 to R2. This is going to be 0.31 ampere. And then the R of 1 is 2. And the R of 2 is 5 ohms. That gets us V1 and V2. 0.31 times 2 is 0.62 volts. And then for V2, we get 1.55 volts. I'm recording. Yes, I am. Oh, shoot. Bailey's in the waiting room. Hey Bailey, I'm sorry I didn't see you were waiting in the waiting room. I didn't realize I had that enabled. Okay. Um, anyway, I guess we'll just talk through what we just did. So we knew this from what we had calculated previously. We saw that 1, 2, and 4 are in series, sorry, parallel. So they have the same voltage, which is how we get this. So we calculated the V12, or we used the V12 to calculate for the I12, which gave us 0.31 volts. Because the resistors 1 and 2 are in series, they have the same I right here. So we were able to go ahead and plug those into the table. And now we're just calculating the individual volts of those using the I and R's, which are already in the table. Are you asking a question? I can't quite hear you. Okay. I think you're just having a conversation, so I'm gonna go ahead and mute you. You're free to unmute if you actually did have a question. Okay. Anyway, so that solves for our V's. And then we can go ahead and solve for our P's. I'm gonna write those in right now. 0.62 volts and 1.55 volts. And then for P, we have P1, I1, V1. And then we have P2 is equal to I2, V2. Our I is at the same, 0.31A. And then our volts are what we just calculated. So 0.62 volts and 1.55 volts, which gives us P1 and P2 as 0.62. P1 is 0.19 watts and P2 as 0.48 watts. Cool. Make sure there's nothing in the chat. Alrighty, so we can go ahead and move on to the next problem. Were there any questions on this problem before I move on? Okay. It asks us if our results are correct or not and how you can tell. The best way that I would say you can tell is probably just the units. The units add up. We could also probably, we could add up the voltages, and that might work. But I think we're gonna have to, I think we probably add up the voltages of R1, R2, and R3, and that should add up to 12. Because we use the other one, the V3 and V4 to originally find it. So if the adding the other direction is also 12, then we were correct. So it's gonna be 6 plus 1.5 plus 9.73. We got 11.9 volts, which we had rounding, so that's definitely close enough. See, what did she say in the key? I don't have it over there. This is her working the key. If you guys need it. She doesn't have anything in the key about the results, so I would probably say adding voltages the other way, but for this one would be pretty good. You could also just go through and double check that like everything's in parallel and it's added correctly, and so like you know that these two are in series, so they have the same I type of thing. But because a lot of them were combined, that might not be such a good trick. What you might also be able to do is add up all the powers, and that should add up to the power of the battery. So if we were to do that, 1.19 plus 0.5 plus, and then we can go ahead and calculate the power of the battery. I'm gonna put B for battery. Our I is gonna be our I total, which I don't think we have written here, but I know we calculated, so it's gonna be over here. I total 1.39 A. I got that one from right here. Total. V total. V. And then battery is 12 volts. So we have that. We just needed that from the other equations. 16 point, I got 16.68 watts, which we got 16.6 watts up here. That's pretty close. Do remember that there's a lot of rounding that happens here, so as long as you're within decimal points, it's usually acceptable. Nice. What time does this class end? 1:40. 1:40. It took way too long on this. We do have a second problem here. You guys are free to go. I'm sure you guys might have other classes after this. I'll probably stay and try and solve this if you guys feel like that would be helpful. It is recording, so even if you can't be here right now, like I'll send Dr. C or send out the video. What do you think? Or should we save it for tonight? Okay. Yeah. Okay.
Unfortunately, Dee, I have to take Nicole to the airport, but I will work on the other problem.
Okay. Sounds good. Yeah, feel free to work on this, and then I'll probably be recording this at tonight's usual supplemental.
Okay. Thank you.
Thank you all for coming. Have a nice day.
Bye.
Bye.
Thank you.
Bye. See you later.